It's Tuesday, February 18th. My name's Juan Brown. You're watching the Blancolirio channel, and today it's time for a 737 MAX update as we get rather deep and wonky into the regulations and the FARs regarding transport category aircraft wiring requirements and its impact on the 737 MAX's return to service. I also want to thank the nearly 30,000 new subscribers to the Blancolirio channel and remind everybody to check your notification setting on the little subscription bell to make sure it's set up to the desired setting so that you're getting the notifications that you want, as often those settings have a tendency to change here on YouTube. Also, thank you for your support on Patreon and PayPal. We just crossed over 1,000 patrons over at Patreon, and 1,000 patrons carries more weight than 100,000 subscribers here on YouTube. And that prevents me from having to answer the spam email I recently got from some VPN providers and selling you a 60-second huckster sale on a VPN network that you probably don't need. So the talk around the headquarters here at Blancolirio headquarters is who's going to fly first, Brownie or the 737 MAX? In case you haven't already heard, I've got my numbers back from my latest PSA test, and my numbers are good. Less than 0.02, virtually undetectable PSA. I've just recently submitted all my paperwork, or my most recent pile of paperwork, to the FAA to get ungrounded myself. That could take as long as 6 months. The 737 recertification, however, keeps getting pushed back, and now airlines are talking about maybe not till the end of summer or early fall at the earliest that they may see the 737 MAX back flying revenue flights. So the work that's been done so far on getting the 737 MAX back on the line is the MCAS system, of course, has been redesigned back to its original design intention. They've added the required amount of redundancy that the system needs, and they've removed the aggressive nature of the design to prevent it from overpowering the aircraft. They've also worked on the two FCCs, two flight control computers, and have fundamentally changed the architecture of the 737 in the MAX design, where they now allow both FCCs to operate simultaneously, both cross-checking each other, and if one disagrees, it throws the other one offline, unlike the original 737 design where it just operates one FCC at a time on each flight. During that process, a problem with the stabilizer trim in op-light came up. I think they got that fixed, and also the boot up of the FMCs, they got that worked out. But what that leaves remaining to be resolved, one is the training. What training will pilots get for the 737 MAX? And Boeing has relented, and there will be simulator training in the 737 MAX simulator for all the pilots that are going to be flying the MAX aircraft. More on the simulators here in a second, but the training itself will not be like an entire redo of your original type ride in the 737. It'll be a differences training in the 737 MAX simulator, which will probably involve at least 1 or 2 simulator sessions. The problem now is, where do we get the simulators? We'll talk about that in a second. And the other big issue that's in the news right now is the wiring issue, and that's what we're going to dive into deep today. Specifically, the wiring involving the elevator trim system, of all things. Test flying is going on will be going on the 737 MAX soon. The 737 MAX aircraft has been doing some flying this whole time while it's grounded. That flying is one-time ferry flights. And my friends up in the Canadian Broadcast Corporation, the CBC, tried to make a mountain out of a molehill of that story and scare to death the folks, the victims of this of the accidents of the two MAXs by trying to make a story saying that the 737 MAX is flying when it shouldn't be, and it's flying when you don't. Did you know about this? These are FAA approved one-time ferry flights. The aircraft were simply coming off the assembly line too fast to be parked in the parking lot, and they needed to move those aircraft out of the parking lot to make room for the aircraft coming off the assembly line. So those aircraft need to do a one-time ferry flight to another destination. And up in Canada, with the coming harsh winter, they had to move a lot of those aircraft that were grounded out of those harsh environments and down into the desert where they could continue to work and service those aircraft. Those are one-time ferry flights flown only with approval by the FAA and with approved crews. Regarding simulators and simulator training, there are thousands and thousands of 737 pilots out there that are going to need this training in the simulator before they can fly their 737 MAX aircraft. And this is going to lead to about a 2-year estimated backlog once the MAX is approved to fly until they clear the backlog of the grounded aircraft and the aircraft that have just come off the assembly line. So it'll be a slow restart of the assembly line. The simulators are built by CAE, or Canadian Aerospace Electronics. These are the folks that build all of our simulators that I see at my company. There are only 36 737 MAX simulators available in the world today. CAE is picking up the ball and running with it and has they've got orders for 48 more simulators, and they've delivered on 23 of these simulators. So CAE is just cranking up the construction of these simulators. They're $20 million a piece. These are the full motion, full visual simulators that are going to be required to get this 737 MAX training complete. Again, this will be just a short course for pilots, maybe 1 or 2 sim sessions. This may be able to be accomplished during regular recurrent training. Nevertheless, these simulators still need to be moved and set up in simulator bays that hopefully have enough space for them. There's also talk from Boeing that maybe they can configure some of the older NG series simulators to emulate the 737 MAX and get the training done in those. So even if the MAX is not allowed to fly revenue flights until well later on into this year, the production line may slowly start back up as soon as April of this year. Now on to the 737 MAX wiring issue. I want to first thank Dominic Gates of the Seattle Times for having the best well-written article on this issue, and for being one of the few journalists in the media that does a good job of covering these issues. Of course, Boeing is his backyard at Seattle. That's his beat. So I'll post a link to his article down below. Transport category aircraft are flown under FAR Part 121. Transport category aircraft are built under FAR Part 25. Like most of the FARs, these things go back to the beginning of time, to the venerable DC-3, and in fact to this day you can still see references to the DC-3 in FAR Part 25. FAA, Federal Aviation Administration, has a dual role: 1, to promote aviation, and 2, to regulate aviation. Now this sounds like a direct conflict of interest, and sometimes it is. And often these regulations don't get changed very quickly at all. They get changed very slowly, very deliberately over time. Over the years, the NTSB, or National Transportation Board, was formed by Congress to investigate accidents and see what we can learn from accidents, and then apply what we've learned from these accidents to change the rules and regulations and adapt as we go through time. But the NTSB is only an advisory committee and cannot make changes or make rules. That's up to the FAA, the regulator. Now, as new technologies become available and as we learn new things from various accidents, the regulations can change to adapt to this. folks that are in the building industry well know building codes are constantly changing, and for new construction, you're constantly having to adapt to the new building code. Well, I would argue that the regulations at the FAA change much more slowly than what you see, for example, in building codes out there in the building industry. But what the FAA can do to quickly change regulations is issue an AD, or airworthiness directive. And in an urgent case, they can issue an emergency airworthiness directive. Compliance with an airworthiness directive is mandatory to maintain the airworthiness of an aircraft. If an issue does not affect directly the airworthiness of an aircraft, a second layer of regulation can be added called an advisory circular. An advisory circular is not mandatory. So now let's go back to 1996. We had the loss of TWA Flight 800 due to the sparking of the wiring in the fuselage tank of that aircraft. And then in 1998, we had the loss of Swiss Air 111 from an electrical fire that migrated up into the cockpit. There was also an issue of holding there with, again, another concern about overweight landing versus land as soon as conditions permit, but that's another story for another time. These two accidents brought to light to the NTSB the consideration of aging electrical wiring in aircraft. So a committee was formed, ATSRAC, or Aging Transportation System. What? The Aging Transportation System Rulemaking Advisory Committee, and did a study on these aging aircraft and their wires. And that committee went from 1999 and was sunsetted in 2006, and the result of all this work was a series of advisory circulars as to how, non-mandatory, as to how the FAA responded to the recommendations of the NTSB. It's these changes to the regulations that is now becoming a problem for the 737 MAX, even though they're not mandatory. And this gets to the bigger problem of trying to keep a single type certificate alive for so many years. When the aircraft was originally certified, things change, rules change. But the Boeing 737 has 205 million flight hours, and of those 205 million flight hours regarding wiring issues, particularly in the elevator or stabilizer trim, they've only had 16 failures and no hot shorts. We'll talk more about that in a second. So in other words, the 737 has a great track record for safety in this realm. But nevertheless, when you look at the 737 MAX wiring, it is following the guidance and guidelines of pretty much the original type certificate rating, whereas today the rules have changed somewhat and now require greater spacing between wires and greater redundancy between systems, and yet the 737 MAX is still using some of the old rules that it was originally certified under. So what's the big concern on the 737 MAX specifically? The wiring bundles containing the wires for the stabilizer trim, the hot wires and the command wires are too close to each other, according to some folks, and now the debate is raging. This was first brought to light, I believe, by folks at Boeing, and now the folks at the FAA have to look at it, and under the white hot spotlight of public opinion and everything that's going on with the 737 MAX right now, somebody has to make a critical decision as to what to do with this wiring issue to bring it up to date. Are they going to separate them? Are they going to require a change to the future aircraft that are being built? If they have to change the existing MAX aircraft, they're going to have to break up those wiring bundles and move them around. That's always problematic whenever you start moving wires around an existing wiring loom. Will this affect legacy models of 737 or previous models? Boeing's looking at the safety record and saying, look, it's a proven effective design. I think we'll do more harm than good if we get in there and start changing this around. So therein lies a giant conundrum. And the The problem, the problem is, could there be a catastrophic loss of an aircraft if there was a short between one of these power leads and one of the command leads to the stabilizer trim? If you were to short out a power lead to a command lead on the stabilizer trim, that's going to run the stabilizer motor and potentially run the stabilizer motor to a full nose up or full nose down trim position, even if you do the correct runaway trim procedure and hit the two trim cutout switches. A short in the wrong place at the wrong time could potentially continue to run that stabilizer trim motor, and that's the concern. And now folks have to figure out what is the mathematical possibility of this happening with the current design. Here's the location of the stabilizer trim cutout switches as previously discussed in previous 737 MAX updates. And the problem specifically with the MAX is that the design has been stretched out so far that once you reach full stabilizer trim throw, as we know from the two accidents, you overpower the elevator, you overpower the crew's ability to recover the aircraft, even with the mechanical trim trying to work against it. Even though these electrical problems are pretty rare, I can give you two examples. One I had on a MD-80 going into Chicago years ago. On approach, configuring, lowering the flaps, and as you lower the flaps and you slow the aircraft to approach speed, you're trimming nose up to trim the nose and obtain your approach speed, so the controls are balanced. During that process, I noticed my elevator trim stopped working. As I lowered the flaps, the nose was getting heavier and heavier. I asked the captain, hey, try your stabilizer trim, mine's not working. He tried his, wasn't working either. So we were already on approach, airport in sight, runway in sight. We decided we'll just hold the flap setting that we got right now, recalculate a new approach speed, set that in the window. Don't mess with it. Review our runaway trim procedures if we need it, and just land with the in-op trim. Yeah, it got pretty heavy in the flare, and I told him I might need a little help here in the flare, but it was fine. I was able to overpower the loss of elevator trim and do a firm landing, and landed uneventfully, and they went and got that trim fixed. But in the back of my mind, I was thinking of Alaska Air, who lost that MD-80 here off of the coast of Southern California years ago. I didn't want to mess with it. I didn't want to try and troubleshoot it, not flipping circuit breakers, especially here on final. Just leave it alone. Another more recent example was the Brickyard Flight 4439, which I gave a briefing on here in November, 6th November, and I went into great detail about how all the fly-by-wire system works on this particular aircraft, trying to figure out why this guy lost his elevator trim in such a severe state that caused him to do a couple of corkscrews until he got the aircraft back under control. Well, that turned out to be a simple chafed wire at, once again, the pitch trim button right on the control yoke. So very rare, but these things can happen. Neither of these examples are specifically what regulators are concerned about on the 737 MAX. So as the rules change over the years, it's very difficult reading the regulations to figure out what are the current rules, what are the current standards for FAR Part 25 transportation category requirements for aircraft wiring, especially now with these layers of advisory circulars added on, amending the regulations. And at this point, I think the confusion is not only between the manufacturers and the maintainers, but the regulators themselves have a hard time determining what is the standard. Let me read this one. Effect of this statement of policy. This is a fallout from the advisory circular on aircraft wiring from the aging infrastructure recommendations by the NTSB. The general policy stated in this document is not intended to establish a binding norm. It does not constitute a new regulation, and the FAA would not apply or rely upon it as a regulation. This is regarding aircraft wiring, bringing it up to code, so to speak. Those tasked with the responsibility of aircraft certification should generally attempt to follow this policy when appropriate. In determining compliance with certification standards, each certification office has the discretion not to apply these guidelines where it determines that they are inappropriate. However, the certification office should strive to implement this guidance to the fullest extent possible to facilitate standardization and ensure that wiring installation details are adequately addressed during certification. Applicants should expect that the certifying officials will consider this information when making findings of compliance relevant to the certification actions. Applicants also may consider the material contained in this policy statement as a supplement to that currently contained in Title 14 CFR Part 21 when developing a means of compliance with the relevant certification standards. Now, what does all that mean? How is somebody supposed to figure that out? So in other words, it's all very subjective, and good luck to the guys trying to sort out the wiring issue on the 737 MAX. It's all under a high degree of scrutiny right now, and public scrutiny, and so they're going to have to do something, and the FAA generally sets the standards for the rest of the world, and the rest of the world's regulators are going to look to the FAA to guidance to see what have you done on this aircraft to get it up to speed. So I hope that clears things up as clear as mud on the 737 MAX wiring issue. As we get more information, we'll let you know. Those of you that are inside the industry that have some more information, leads, or links that can help us decipher what's going on with the 737 MAX, we'll look forward to your comments in the comment section below. See you here. It's just as clear as mud.